Hello, Assalamualaikum warahmatullahi ta'ala wabarakatuh. My name is Abdul Rahman Huzaifi bin Fadil and you can call me Aman. I'm one of the UNIKL MIA student. Today I would like to present about sound and optic. Hope you guys can enjoy it. Okay, sound vibration. Sound vibration causes waves which radiate out from their source at the speed of sounds. Aircraft moves less than the speed of sounds. The sound moves ahead of the aircraft. The aircraft lies at the speed of sounds produce shock waves. Let's take a look at the Mach number. The ratio of the speed of the airplane to the speed of sound in the same atmospheric conditions. Mach number equal to speed of the aircraft over speed of sound. Resonance. Resonance is the natural frequency of a given object vibrates naturally or without the external force. Two objects have similar frequency. If one vibrates, the other can move too. We call it destructive force. Waves. Waves property. The period t of a wave is the time required for one complete wave to pass a given point, and thus frequency, which is f, equal to 1 over t with its unit hertz. The wavelength, which is lambda, is the distance between adjacent wave crests. Velocity, v, equal to frequency f multiply wavelength, which is lambda, with the equation is v equal to f lambda. The amplitude a of a wave is the maximum displacement of the particles of the medium through which the wave passes on either side of their equilibrium positions. The intensity I of a wave is the rate at which it transports energy per unit area perpendicular to its direction of motion. Sounds. Sound waves are longitudinal waves that consist of varying pressures. They can travel through solids, liquids, and gases. The region of sound waves consists of regions of compressions and refractions that follow each other. The changes in pressure cause our eardrum to vibrate with the same frequency. This produces the sensation of sound. The speed of sound is a constant for a given material under a given conditions. When sound waves spread out uniformly in space, their intensity decreases inversely with the square of the distance r from the source. Thus, if the intensity of a certain sound is I1 at the distance R1, its intensity I2 at the distance R2, it can be found from the equation I2 over I1 equal to R1 2 over R2 2. Sounds. Sounds travel at different speeds in different materials. Air is poor conductor, water is better, and solid is the best depends on the molecule arrangement. More dense the solid material, the better conductor, which is sound travels faster. At sea level, at standard atmospheric condition, sound travels at 761 mph, which is 661.2 knots, or about 1116 feet per second, which is 340.4 meters per second. In water, sound travels much faster at 1435 meters per second or 2789.6 knots, since water is denser than air. Sounds. In air, only speed of sound varies directly with temperature, not pressure, because a change in temperature of atmosphere change the density without affecting the pressure. Under standard atmospheric condition, the temperature of air decreases with increase in altitude. Speed of sound decreases with altitude about 30,000 feet, then remain constant to more than 100 feet. When airplane moves through the air, it creates sound waves which radiate in all directions from the surface. If airplane moves as fast as the sound waves, these waves cannot go out ahead of it. Instead, they pile up in front of the airplane and form a thin pressure line. This is called a shock wave, and it produce sonic boom. Sound Doppler effect. You can see the equation below where VL equal to sound velocity of the listener and Vs equal to sound velocity of the source. Now let's have a look at the optic. Nature of light. Light waves are part of a group of electromagnetic waves or radiation that includes X-rays, ultraviolet, infrared rays, and radio waves. Light waves have a certain properties which are common. These are A. They travel through space at the speed of light, which is 186,000 miles per second, which is 3 million kilometers per second. B. They obey the equation V equal to F lambda. C. They carry energy from one place to another, and on absorption cause a rise in temperature of the absorbing body. Okay, light dispersion. Within the light spectrum, there are 6 colors that can be readily identified, which is red, orange, yellow, green, blue, and violet, with indigo being difficult to distinguish. These are two examples of light dispersion. Within the light spectrum, there are 6 colors that can be readily identified, which is red, orange, yellow, green, blue, and violet, with indigo being difficult to distinguish. Sir Isaac Newton was the first person to explain this band of colors known as the spectrum using glass prism. Reflection. Reflection is the change in direction of a light wave when it bounces off a boundary. There are 2 laws of reflections. One is the angle of incidence, which is I, is equal to angle of reflection, which is R, and the second one is the reflected ray lies in the same plane as the incident ray and the normal at the point of incidence. These laws of reflection apply equally to curved and flat surface. Curved mirrors are of 2 types, which is concave and convex. Concave and convex mirror. A concave mirror is a surface that is shaped in towards the middle and away from the observer. A convex surface is a surface where the center is shaped out towards the observer. It is in opposite direction to a concave surface. This is a concave mirror and this is a convex mirror. Concave and convex mirror. A concave mirror is a surface that is shaped in towards the middle and away from the observer. A convex surface is a surface where the center is shaped out towards the observer. It is in opposite direction to a concave surface. This one is a concave mirror and this one is a convex mirror. Point P is known as the pole and is the center of a curved mirror. Point C is the center of curvature and is the center of the sphere of which the curved mirror is part. Point F is called the principal focus or focal point. In the case of concave mirror, this is the point where rays are converged. Meanwhile, for a convex mirror, the rays diverge. Refraction. Refraction is a change in direction of the light ray occurs when light rays move from one medium to another. Example, air to water. This is called refraction. The direction in which they are refracted depends upon whether they move into a more dense or less dense medium and respectively slow down or speed up. Observation on light refraction. The ray of light is bent towards the normal when it enters an optically denser medium at an angle. The ray of light is bent away from the normal as it enters an optically less dense medium as it moves from glass to air. Should the ray be arranged to enter the block along the normal at 90 degrees to the surface, it is not refracted. Light refractive index. The equation is refractive index n equal to velocity of light in a vacuum divided by velocity of light in the substance. The refractive index, which is n, depends on the wavelength of the light. In a vacuum, light waves travel at 3 million km per second, whereas in glass the velocity falls to 2 million km per second. Snell's law. Snell's law said that sin theta 1, which is angle of incidence, divided by sin theta 2, which is angle of refraction, equal to a constant, which is c. The ratio of the sine of the angle of incidence to the sine of the angle of refraction at the boundary of the two substances is always constant. The constants may be expressed as the refractive index of substance 2 with respect to substance 1, that is 1 and 2, which is the equation is sin theta 1 divided by sin theta 2 equal to 1 and 2, which is the relative refractive index. Okay, now lens. There are two basic lenses. Convex lens, or also known as converging lens. The other one is concave lens, or known as diverging lens. The distance between the focal point and the optical center is known as the focal length and is given the symbol which is f. It is on this value that the calculation of power is made, which is the equation is power equal to 1 divided by f. Electromagnetic waves. Electromagnetic waves, which is light, consists of coupled electric and magnetic fields that vary periodically as they move through space. These fields are perpendicular to each other and to the direction of the wave, hence the waves are transverse. It requires no medium to travel and can transport energy. Radio waves, light waves, X-rays, and gamma rays are examples of electromagnetic waves. Characteristic of light, apparent depth. An object submerged in water appears closer to the surface because the light leaving the surface bends away from the normal as it leaves. The object also seems shallower than it actually is. The ratio of apparent depth and true depth is equal to refraction index of liquid and refraction index of air. Lens. There are two basic types of lens, converging and diverging lens. Properties of lens, focal length. The focal length of a thin lens is given by lensmaker's equation 1 over f equal to n minus 1, 1 over r1 plus 1 over r2, where n equal to index of refraction of the lens material to the medium it is in. R1 and R2 equal to radii of curvature of the two surfaces of the lens. A positive f corresponds to a converging lens and negative f to a diverging lens. And that's all from me. I hope that you enjoy it and see you next time. Bye.